Alrighty guys, in this part C, we're going to be using a trapezoidal sum to approximate the average height. Average height? Hey, how convenient. I have a function for height. So when we have matchy-matchy, I want the average height. I have a function for height. It's no big deal. We're going to use the average value formula. So anytime they're matchy-matchy, we're using our average value formula. All right, so average value, recall, is 1 over b minus a times the integral from a to b of whatever that function is. So f of x dx, whatever that function is. In this case, it's the height. So this would be the average value of f of x, and we're looking for the average height, so we're going to do very similar. We're going to come down here and we're going to say from 2 to 10, so that's going to be 1 over b minus a. Well, there's a, there's b, so 1 over 10 minus 2 times the integral from 2 to 10 of h of t dt. Now this says that we're going to be using a trapezoidal sum to approximate this. So what that means is this integral is going to be approximated using a trapezoidal sum. So it helps to recall what the area of a trapezoid is. The area of a trap is equal to 1/2 times the height of the trapezoid times base 1 plus base 2 of the trapezoid. Now remember, with a trapezoid, the height was found by delta x. The change in x is your height. And the base 1 and base 2 would be your outputs, your first, second output, your second, your third, and so on and so forth. So for our first trapezoid, this delta x is going to equal our height. And this could be our base 1 and base 2. All right, and if you want to get a visual on that, just a real quick sketch of what a trapezoidal sum would look like. Here's my function. This is just a random function I'm using just to explain this process. And I would use a trapezoid to approximate the area under that curve. And I could use another trapezoid. There's a little example with 2 trapezoids. And when I teach trapezoids in geometry, I talk about the bases being the parallel sides. So the parallel sides would be this guy and this guy. So that would be the y value there would be your base 1, your output. And your output here, that length would be your base 2. While your height would connect your 2 bases. That's what I teach in geometry. So this length right here that connects the 2 bases, my delta x, would equal my height. So that's a quick rundown of what a trapezoidal sum looks like. And you would do that for every trapezoid and add them all up. So, let's do it. Let's approximate. That's going to sit out in front because that's how I know it's an average. And then my trapezoids, I'm going to have 4 of them. My first one is going to be 1/2, and the height is going to be delta x. So the height is going to be 3 minus 2, 1. And then my 2 bases will be 1.5 and 2. 1.5 can be base 1, and 2 can be base 2. All right, so there's one trapezoid. Next trapezoid, 1/2. And the height this time, delta x, is going to be 2 because the change in x is 2. And then my base 1 is now going to be 2, while my base 2 is going to be 6. So 2 plus 6. And I keep doing this. So my delta x here is another 2. And my base 1 now is going to be 6, while my base 2 is going to be 11. And another one. Delta x is going to be 3, and base 1 is 11, and base 2 is 15. Cool. Well, guess what? That's a good answer. In fact, that's a really good answer. So I could leave my answer like that and be done with this video, but just for schnitz and giggles, I'm going to keep on rocking. So 1/8, writing in purple because I don't really need to do this step. And maybe you've already shut the video off at this step. So 1/2 of 3.5 plus 8 plus 17 plus 3/2 of, is that 26? So the reason you don't have to keep going is because this is where people are going to make mistakes, and you don't have to do this part. I don't know why I'm doing this part. Half of 3.5. I don't know what half of 3.5 is. 1.75. And then 3/2 of 26, that's 13 times 3, that's 39. So 1/8 of all that. I'm gonna stop. This is getting ridiculous. You could keep going because you're smarter than I am. But that's what we're doing. That's the plan. I should have stopped a long time ago, but I didn't. So our correct answer was right here. All right, guys, one more part of this question.